Good morning. I am Sri Lakshmi from the Center of Earth, Ocean and Atmospheric Sciences. Today I'll be talking about the topic of seismic waves. The energy gets radiated and passes through the earth before and after, during and after an earthquake, and these are called as the seismic waves. As we all know, a wave has the highest point as a crest and the lowest point as a trough. The distance between two crests or two troughs is said to be as the wavelength, and the distance, the height of the wave from the center of the crust is said to be as the amplitude. The types of seismic waves: the body waves and the surface waves. The body waves are further divided into P waves, primary waves or the longitudinal waves, S waves, secondary waves, shear waves, and the transverse waves. The surface waves are divided into La waves and Rayleigh waves. The body waves are the waves which passes through the interior of the earth, and the surface waves are the waves which reach to the surface and travel along the surface are said to be as the surface waves. The body waves said to be recorded in the seismogram first because they are the fastest waves, and the secondary waves travel at the back of the primary waves and they reach later the seismometer and they get recorded in the seismometer. The primary waves are said to be as the P waves. These are the fastest kind of seismic waves, and the P waves move through the solids and fluids in the interior of the earth. They have a pull and push of the rock as they move and propagate through the rock media. The P waves travel with the highest velocity of about 6 kilometers per second in the crust. The P waves have a form of alternating compressions and rate fractions. So, as the wave propagates, the particles move away from their location in the form of compressions and rate fractions, and as the wave passes away, the material regains its original shape. The secondary waves are the shear waves. The S waves travel a little slower than the P waves and they move only through the solid waves. They travel with a velocity of about 3.6 kilometers per second in the crust. The motion of this wave is said to be as up and down and side and side. The particle motion is said to be in a transverse in nature. So, as the particle moves away through particles, they get dislocated from the positions in an up and down direction, and as the wave propagates away, the material regains its original shape. The type of seismic waves The second type of seismic waves, as we all know, are the surface waves. They are classified into Rayleigh waves and the Love waves. The Rayleigh waves had the ground movement of up and down and is said to be of a retrograde elliptical pattern. The Love waves move horizontally back and forward as a form of a snake. The Love waves are named after the famous British mathematician UoH Love in 1911. The Love waves are said to be as the fastest surface waves and they move along the ground from side to side. They have a motion of about the alternate traverse motions. The amplitude of the wave decreases as they pass away. The Rayleigh waves are named after the famous scientists John William Strutt and Lord Rayleigh in 1885. A Rayleigh wave rolls like a wave, just like a wave that rolls across a lake or an ocean. As it rolls, it moves up and down and side. So it has a two movements, up and down motion and side motion. Most of the shaking we feel from an earthquake is mostly from the Rayleigh waves, and these waves are said to be most larger seismic waves than any waves. The particle motion is said to be retrograde and an elliptical motion. The amplitude decreases with respect to depth. Thank you.